All right, guys, we are still working with equations of circles. Remember that we learned what center radius form is, okay, where you insert the center, okay, and for the H and the K, and the R for the radius, okay. And we use that form of our equation, okay. We know we can expand it and get it equal to 0, and that's called general form, all right. So in number 1, just a little review, which of the following equations would have a center of -3/6 and a radius of 3? So if you really want a quick hint, usually look at the radius first and remember that after the equal sign here is the radius squared, and so we would turn that into 3 squared, which is 9. And if you look at choice 3 and choice 4, they forgot to square their R, so those are gone. Okay. Also remember when you put -3 in for H, okay, that it actually makes the sign opposite because there's already that minus built into the formula. And so you're looking for a +3 group with the X, okay, and that's choice 2. All right, double check the Y. All right, but when you put that 6 in, you're looking for Y -6, which is also right there along with your radius squared. And so that's why we are picking choice 2. Okay. All right, let's go ahead and take a look at next 3. It says determine the center and the radius. So based on given the equation, are we able to state the center and the radius for them? Okay, in simplest radical form for each equation below. So in number 2, okay, we'll go ahead and take a look at the center. And it's going to be +9, +3. Okay, our radius. Remember that this number here represents your R squared. So to get rid of the square, we square root, and the square root of 49 is 7. And so our radius is 7. Okay. Number 3 is a little bit different. We haven't seen this before, all right? But they got these 3's here, see them? So what we're going to do in order to make this equation just like the one we just finished and what we've seen before is that we're going to divide by 3. But if we divide by 3 on the left-hand side, we got to divide by 3 on the right-hand side. And so what happens is that when this gets divided by 3, and this gets divided by 3, we just end up with x plus 6 all squared plus y minus 5 all squared equals 54 divided by 3, which is 18. And now we can go ahead and say now the equation looks like it's supposed to in center radius form. Okay? And so our center would be -6, +5. Okay? Our radius, remember, after the equal sign, this is our R squared. In order to get rid of the square, we have to square root. And so we could say the square root of 18. All right. It's not perfect. And so we would leave it as the square root of 18. But the directions also say simplest radical form. So what we're going to do is we're going to break up that square root of 18 into the square root of 9 and the square root of 2. And that becomes 3 square root of 2. So we're going to get rid of this and have a nice simplest radical form answer for our radius instead. Okay. Number 4. We can go ahead and state our center. Nothing group with the x, so we take it as a 0, and then with the y it would be a -1. Okay. Go ahead and look at our radius. Remember that this number after the equal sign represents your R squared, and so we have to go ahead and square root it so we know what R is, and that's the square root of 32, which isn't perfect. And we could leave it like that, but just like in the last one, they're going to make us simplify that radical. So we're looking for the largest perfect square that goes into 32, which is 16. Okay, the other number would be 2, and therefore this would become a 4 square root of 2. And so we'll replace this with a simplest radical radius, okay, of 4 square root of 2. Okay, all right. Let's go ahead and take a peek at what we got next. So we also talked about general form, where you expand your parentheses, okay, and you get it equal to 0 and you order your terms. We are going to go from general form back to center radius form, all right? And it does involve completing the square, but it's not the same exact process as when we were completing the square with quadratics because we're not going to be solving. We're basically just going to be using that B work. So if you remember, in completing the square, once we get equal to 0 and we move C and we pull A, we do something to the B, okay? And with that B, remember what we do to it is that we cut it in half or divide it by 2, okay? And then we take that value and we square it. So we're going to still be doing that part of it, okay? All right, so here we go. First thing to do is when we're doing this is that we want to separate our x's from our y's. So we basically want to unorder the terms that we just ordered to get it into this form. This one's kind of already set up because that 10x and that y squared should have actually switched places in order to be in general form, okay? But what we're going to do is we're going to go back to x squared plus 10x. And then if you remember, there used to be a number there, but that number got combined with another number and another number, okay? All right, but we got to go back to figure out what that number is. Okay? We also are going to have that plus y squared minus 2y, and there was a number here too that got combined. Okay, and we're going to keep that equals 10 on the other side. All right. Again, this equation that they gave in number 5 isn't exactly in general form because the terms aren't ordered and you're not equal to 0. Okay, so they start us off kind of in a weird spot. All right, so here's what we're going to do. We're going to do that b value here. Okay. What's nice about these equations is that they're typically already only x squared and only y squared, which means you're ready to do that b work. Okay, because remember, you can't complete the square unless you just have that x squared term. Okay. All right, so our b value is 10. We're going to take half of it, which is 5, and then we're going to take that 5 and we're going to square it, and we're going to get 25, and that's the number that goes on the line. However, you have to remember you can't just add 25 to the left-hand side of an equation. You also have to add it to the right-hand side. Okay, and now we're going to go ahead and do the same thing with the y's. So we're going to take a look at the b value for the y's, which is -2. We're going to cut it in half to get -1, and then we're going to square it to get +1. And that's the number that goes on the line. And then remember, you have to add the same thing to the other side. Okay, and so now what we did was we made this a nice perfect square trinomial. Okay, if we go ahead and multiply to 25 and add to 10, you're going to find the same numbers of 5 and 5 that are going to do the job. And so this can be rewritten as x plus 5 times x plus 5. Okay, we're going to now do the same thing for the y's. Okay, so we're going to set up an x box for the y's. Okay, with the y's, our multiply is 1 and our add is -2. And we're going to find the same numbers that do the job, 1 and 1, except they both have to be negative. So that those two negative ones multiply to a +1 and they add to a -2. Okay, so we're going to keep the little connector plus sign, okay, and we're going to take this trinomial. It's a perfect square trinomial because we completed the square by doing that b work, and it now factors into 2 of the same factors of y minus 1 and y minus 1. Okay, we're going to keep the equal sign and we're going to go ahead and add these three numbers together. So 25 plus 10 is 35 plus 1 is 36. We have one more step and we will be in center radius form. Okay, because this is the same factor written twice. Okay, we're going to go ahead and rewrite it as x plus 5 all squared plus y minus 1 all squared equals 36. And ta-da, we have center radius form. All right, so hopefully you get to see how we go backwards. All right, we're going to go ahead and state our center as -5, +1, and our radius is the square root of 36, which is 6. Okay, so before we would have been able to tell what our center and our radius is because they gave it to us in not center radius form. But by completing the square for the x's and the y's, okay, remembering to add the same amount on each side of the equal sign, we were able to get it back into center radius form, and then we could tell our center and radius. All right, so we're going to try it again in number 6. Hopefully we got enough room over here. I'll have to write a little bit smaller. Okay. But this is a little bit better in center radius form, or in general form, because your terms are ordered in this one, unlike 5, and you are equal to 0, unlike number 5, okay? All right, so here we go. We're going to go ahead and take our x's and write them first. So we have an x squared term, and then we have a minus 12x term, and then we're going to have another term right here to make that a perfect square trinomial. Okay, so that's gone, that's gone. Okay. Next up, we're going to put plus y squared, and then the y term of plus 14y. And then we're going to have another number here that makes that a perfect square trinomial. Okay. The only thing we have left is 73, and that 73 is going to get kicked back to the other side. All right. And when it goes to the other side, it's going to become a -73. And you have to remember that whatever you put on that blue line in the first part there has to go there, and whatever you put on the red line in that second part has to go there. Okay. So you're adding the same amount to both sides. All right, we're ready for our b work. So with the x's, our b is -12. We're going to cut it in half to get -6. Then we're going to take it and square it to get 36. And 36 is going to go on the line here and on the line here. Okay, For our y's, our b value is 14, and we're going to cut it in half to get 7, and we're going to take it and square it and get 49. And 49 is what's going to go on the line here and there. So we'll squeeze it in. Okay. All right, so now we're ready for our x box. For the x's, our multiply is that 36, and the add is negative 12, and you're going to find that it's the same number and the same number, both negative 6's that are going to do the job. And so now we're going to take this perfect square trinomial, and we'll factor it into x minus 6 and x minus 6. Okay, now we're going to do the same thing for the y's. So the x box for the y's, our multiply is 49 and our add is 14. And we're going to find that it's 7 and 7. Okay, and so we're going to take this nice perfect square trinomial, don't forget the connector, okay, and factor that into y plus 7 and y plus 7. Okay, and now we're going to go ahead and do the part after the equal sign there. Combine our three numbers of negative 73 plus 36 plus 49 for a grand total of 12. Okay, we have one more step. We're going to rewrite this as x minus 6 all squared plus y plus 7 all squared equal to 12. And now we are finally in center radius form. And so I can tell you that the center is positive 6, negative 7, and it has a radius of the square root of 12. Okay. However, that is not a perfect square, and it can go lower. So we're going to go ahead and off to the side here, break it up into 4 and 3, which becomes a 2 square root of 3. And so we'll replace this with 2 square root of 3 so that our radius is in simplest radical form. Okay. All right, guys, we'll go ahead and do a few more problems on the back, but it is the same procedure over and over again. And so hopefully we'll get used to the process. All right, I'll see you guys in the back.